Oh, beautiful day. Well, today we are going to talk about sets from the foundation basis. It's so beautiful that most often than not, we talk about sets. And somebody will ask you, what is Surds? Well, we're not going to answer the question by giving a definite definition, but we are going to break it down in such a way that at the end of the day, we will be able to define what is the meaning of said or such as SURDS. Okay, now let's go to the drawing board and see what we can do. So let's go to our drawing board. Okay, then let's talk about surds. Beautiful surds. Okay, surds. 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 This, when we have values like a square roots, we say with square roots, we always know that square roots is given by the sign. Okay, then if we define it by a variable, let's say a, then we say square root of a, then we say square root of a. So you can say square root of b, square root of c, etc. Okay, now when we talk about square roots, okay, let's consider this numbers over here. If we have square roots of 1 and a square root of 2, okay, square roots of 3 and a square root of 4 and that of 5, square root of 6 up to square root of maybe 25 and a square root of 36 and a square root of 37. Now when we look at this, we know that if we use our calculator and we punch these numbers, we are going to get some respective values. Some of the values will be decimals. For instance, the square root of 2, we always know that the square root of 4 is 2. And the square root of 25 will be 5. And the square root of 36 will be 6. And the square root of 37, when we compute, we are going to get a decimal value. Okay, now let's look at square root of 3. The same one, we're going to get certain decimal values. So the certain decimal value. 2 will give us a certain decimal value. But 1, square root of 1 will give us 1. So as you can see, if you look at it very carefully, this set of numbers, okay, then somebody will ask the question, okay, somebody will ask the question, yeah, that question will be, what, this, you see, all these numbers, these are whole numbers. Whole numbers. Okay, somebody will ask that question, say, what about the square roots? Yeah, what about the square roots between numbers root 2, root 3, root 5, root 6, yeah, root 7, root 8, etc. This sort of numbers is called surds. So this set of numbers. So this, yeah. So our answer will be this, yeah, sort of numbers is or are called surds. You understand it? Yeah. So this is a square root that cannot be written as a whole numbers. Okay. Okay. So this is a square root that cannot be written as whole numbers. Okay, so as we can see, so the question is, what about the numbers that are found, yeah, between this sort of numbers, yeah? So that are found between 2 root 2, root 3, root 5, root 6, and etc. So this is a square root of numbers. This is a square root of numbers that cannot be written as a whole numbers. Okay, fantastic. Now, what about if we have a square root of 2? Well, what about we have a square root of 2? When we use our calculator, the square root of the number root 2 will be dot 1 dot 4 1 4 and etc. Okay, so solid, and as you can see it, we can say that so surd is a what? Rational number. So surds, yeah, is a rational number. Okay, now with all this, we're supposed to have a certain rules, okay, that governs, that help us to understand how the whole set is about. Okay, now if I say in real life, let's talk about the rules of sets. The rules of surds. The rules of surds. Okay. Now, if I have numbers such as root 4, let's say square root of 4 times square root of 9. Okay, this can be written as, because they are multiplying, you say square root of all 4 times 9. Okay, square root of all 4 times 9. Okay, square root of all 4 times 9. And when we know that when we multiply 4 times 9, it's 36. And it's still under the square root sign, 36. So, with this, we can confidently say that the square root of 36 is 6. So now we see that we see that we can multiply 2 or more numbers which have square root signs. You see, it's square root of 4 times square root of 9. Straight, we realize that we can put them together as far as they are multiplication. They are multiplying. So they are, yeah. So that will be square root of 4 times 9, and now it becomes square root of 36. And we all know that the square root of 36 is 6. So we've realized that we can do multiplications in Surds. Okay, it's so beautiful. So in variable terms, we will say that if we have square root of A times square root of B, then we can say that they all carry the square root sign, and you can say A times B. But we know that when we multiply A and B, it will be AB. So this one will be square root of AB. Beautiful. So multiplication holds when we are doing something like division. Okay, division. If we have square root of 36 dividing square root of 9, we know this can be written as square root of 36 dividing square root of 9. Okay, because they are dividing. This sign elementarily is not. It means division. Okay, so square root of 36 divided by square root of 9, you see, it means the square root of 36 will be the numerator and the square root of 9 is denominator. So you see, this is what? Our numerator, and this is denominator. Beautiful. So let's talk about the division one as well. So when two numbers like square root of 36 and square root of 9 are divided, so then we can say that square root of 36 dividing square root of 9 can be written as all square roots 36 divided by 9. Yeah, don't forget. So this signs square root all divided by 9. We know that 9 will not go into 36, or what? We know 9 can go into 36 because we know that 36 divided by 9 is what? 4. So that means it's the square root of 4. Okay, and this square root of 4, we all know, is 2. So division also what holds when we are talking about surds. So you see, as we can see, we have this and that. Okay, square root of 36 dividing square root of 9. We know that this can be written as square root of 36 over 9 altogether, sitting under the square root. And we know 9 goes into 36 4 times. So it will still carry the square root of 4. And the square root of 4 is 2. Well, we can further break this one down also as, since we have square root of 36 dividing square root of 9, okay, this also we can treat them individually. Why? Because we know that it's this only division sign that we have here. And we know square root of 36 alone will be 6 times 6. So that will be 6. And the square root of 9, we know the square root of 9 will be 3. So let's show what is true. So the square root of 36 is 9, and the square root of 9 is 3. Okay? It's 3. So when we put a 3 back here, and we know that 6 divided by 3, yeah, it will be 2. So everything has shown us that this divisible rule in sets holds. So you see, our answer we got when we treated this one individually, the sets individually, was 2. And at the same time, when we put them together, 36 over 9, that gives us 4, and we have 2. So this is the same as that. Okay? Bear in mind. Okay? So that's beautiful. Okay. Now let's look at it in a variable sense. Variable sense. So imagine if we have the square roots of A dividing square root of B, as we learned earlier, if we treat them in terms of variable A and B, then this we know is square root of A divided by square root of B, which is the surd. We saw earlier that these two can be put together. This one, these two, as far as they are dividing, can be put together, and all of them have to sit under the square root, which is surd. Okay, so our answer, yeah, is equals to all of them sitting under A and B. Okay, so that can be written as this. Fantastic. So please look at it very carefully. Let's recap. So we saw that the square root of 36, yeah, this divided by 9 can be written as this. Yeah, can be written as this. And the top one, the numerator, and the down one, denominator. They're the same, 36 root 9. When we put them together on the third form, will be like this. Then, when we broke them together, we have this. Now, we have looked at multiplication and division. Do you think addition? So our question is, does the rules of surds also holds for addition and subtraction? Okay, that's the rules of surds also holds for addition and subtraction. Let's see, because earlier we saw that multiplication and division holds for rules of surds. Now let's look at it. Okay, so if we have square root of 4, okay, square root of 4, surd 4 plus surd 9. You see, that is addition. This is addition. Okay, square root of 4. Please look at this with carefulness, because forever you're not supposed to, make such mistake that people are fond of doing. Okay, so you see that square root of 4 plus square root of 9, that's addition. So our question means, if we have square root of 4 plus square root of 9, does it also hold? Can we say, okay, now the questions say, yeah, can we say that square roots of 4 plus square root of 9 can be written as square root of 4 plus 9? Okay, the answer is no. Now you see the reason why I'm saying that is no. Now let's see. So let me put it down so that you don't forget. So the answer, yeah, the answer is no. The answer, it's no. Please do not forget. The answer is big no. Big no. No. Okay, you will never ever forget. Why? Because why? Somebody's asking me why. Somebody's asking me why. Is it that square root of 4 plus square root of 9 is not equals to square root of 4 plus 9? Somebody doesn't understand. The rule is the addition of sets does not hold. So this is questionable. I'm going to explain the reason why it's questionable. Because square root of 4 plus square root of 9 cannot be written, cannot be written or agree that they are the same. Now let's look at why they are not the same. So the reason why addition does not holds. So we cannot add surds straight on. We cannot add as compared to division and multiplication. Now let's look at it. Okay, so our question in focus is square root of 4 plus square root of 9. Okay, square root of 9, is it equals to square root of 4 plus 9? No, it's not. Okay, now let's see. What if we take them one by one? Okay. We see that the square root of 4 is 2. When we find a square root of 4, when we use our calculator to find the square root of 4, it's 2. At the same time, square root of 9 is what? 3. So when we add them, we will see. Now let's come here. 4 plus 9 is 13. So this is 13. So when we put them together, 2 plus 3 is 5. Does it equals to 10? Does 5 equals? Do you think 5 is equals to 13? No, it's not. So we say this is not. So now you see the reason why the square root of 4 plus square root of 9 cannot be the same. So addition does not hold in surds. Now let's look at it. Let's look for one more example. Okay. If we have square root of 64 plus square root of 49, can can we say it's the same as, can we, yeah, can we say it's the same as, can we say it's the same as square root of 64 plus 49? No, it's not the same, because the addition in sets is questionable, does not hold. So square root of 64 plus square root of 49 is not equals to square root of 64 plus 49. Let's see. Square root of 6 is what? 64 is 8. 8 and 9, square root of 49 is 7. And when we add 49, okay, when we add 49 to 64, yeah, guys, do the calculation. Let me see. What do you get when you add 64 to 49? You see, you get square root of 113. Okay, square root of 113. Okay, and 8 plus 7 is 15. Okay, now if we find the square root of that, what do you think we're going to get? Yeah? Who can tell me? Use your calculator to find it. Let me see. The square root of that will be 11 point certain values. So you see that this 15 and 11 are not equal. So addition does not hold. Okay, now let's look at let's make our point. Let's make our point here. In the same way, okay, we say that note, remember, there is not, okay, rule for addition or taking away of surds. You cannot add surds by adding or taken away from each other. Yeah, please bear that in mind. Now, with this very important note. Beautiful. Now, let's look at subtraction. Subtraction of surds. So sub as subtraction of surds. Okay, so subtraction of surds. Now look at it. if we have square root of 9 minus square root of 4, this is not equal to by saying that square root of 9 minus 4 as well. Why? Because square root of 9, we know it to be 3. And the square root of 4 is 2. So with minus, this is not equal to, you see, 9 minus 4 will be 5. So square root of 5, okay? Now, if you use your calculator to compute these values, you will see that 3 minus 2 is 1. This is not equal to square root of 5, which is 2 point something, certain decimals. So you see that in subtraction, we possibly cannot do that as well. Unlike that, we know that division and multiplication, we can apply to surds. Now let's look at some examples. 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 Okay, so examples. Okay, so if we have square root of 9 times square root of 9, okay, with this, we can say, what they are multiplying, we can say this is square root of 9 times 9. Okay, and when we break these ones down, you see that square root of 9 is 3. Multiplying by another 3, okay, and the square root of 9 times 9 is the square root of 81. Let's see what is true. 3 times 3 is 9. So you see that for the left hand side, our answer is 9. Let's see if we can get the same value for the right hand side. Look at the right hand side, square root of 81 is 9 as well. So, yeah, this implies that multiplication holds. Okay, so multiplication, yeah, is possible in surds. Okay, isn't that beautiful? That is a beautiful example. Now let's look at the square roots, the same number. Okay, if we have the same number, if we have square roots of 9, okay, dividing square root of 9, yeah, how do we go about this? It is the same as saying that square root of 9 divided by square root of 9, and this can be written as square root of 9 over 9. Okay, can we say that? Yes, because we know that square root of 9, this is 3. Yeah, 3 divided by 3. And 3 divided by 3, we know its answer is 1. Over here as well, we know that square root of 9 and square root of 9 can be written as square root of 9 over square root of 9. And this 9 over 9 is 1. So square root of 1 is 1. So you see that the left hand side is the same as what? The right hand side. Now, let's take the same number and apply it to addition. Addition. Okay, so square root of 9 plus square root of 9. Can we say it's the same as square root of 9 plus 9? You see, this addition. Yeah, this is addition. Let's see whether it's true. We can say the same. So this is addition. Okay, addition. Let's see whether it's true. So square root of 9 plus square root of 9. Okay, now on the left hand side and the right hand side, you see the square root of 9. We know that this will give us 3, and this will give us 3, and this, we know this is square root of 9. 9 plus 9 is 18, sorry. Okay, 9 plus 9 is 18. And when we add this 3 plus 3 is 6. Okay, and this is square root of 18. What is the square root of 18? Who can tell me? It's 4 point certain value. So even if it's 4, they say that 6 is not equals to 4. So now we have seen that the same number, square root of 9, when we put them together, okay, we can say that square root of 9 plus 9 will be square root of 18. It's wrong. Okay, beautiful. But this square root of 9, okay, now let's look at it, how we can write it in the other way. The same square root of 9 plus square root of 9. Okay, when we apply something we call factorization. 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 When we say simplify this in terms of factorization, you see that our square root of 9 plus square root of 9, plus square root of 9 can be written as, we can put square root of 9 out and we say 1 plus 1, because when I multiply square root of 9 by 1, I will get square root of 9, and I multiply square root of 9 by this will be square root of 9, and that will give me that will give me this, the left hand side. Okay, and this is the right hand side. Okay, so square root of 9 plus 9 can be written like this, square root of 9. Okay, now we have 1 plus 1. Okay, so square root of 9, and this means it's multiplying. Square root of 9 multiplying 1 plus 1, and we know 1 plus 1 is 2. Therefore, we can write this set as 2 root 9. Okay, the 2 root 9 is the same as 2 multiplying square root of 9. Please take note of that. Root 9 plus root 9. We know that we cannot say that it will be square root of 18. That is wrong, whereas we saw earlier. But we can write it in this way. We can express it in this way. So we saw that square root of 9, okay, we bring it out and we put 1 plus 1. Because when we expand, root 9 multiplied by 1 will give us root 9. And root 9 multiplied by another 1 will give us root 9. So we have left with 1 plus 1 in the bracket, multiplying the square root of 9. And you know 1 plus 1 is 2. So this, as you see like that, is multiplying. So that this can be expressed as square roots, 2 square root of 9. Okay, so that is exceptional case when we can add numbers. Okay, well, we can add numbers, so it will become 2 square roots of 9. Okay, now, so addition, it didn't work. Okay, now, a special case special case for, special case for addition, okay, and subtraction in Surds. Okay, so let's look at a special case. Our special case, look at it. If I have square root of 9 minus square root of 9, okay, this can be written as square root of 9 minus 9. It's only special case. And we know that square root of 9 minus square root of 9 is 0. And over here, also 9 minus 9 will be 0. Square root of 0 will be what? 0. That's the special case. Okay? So even if I have square root of 13 minus square root of 12, I cannot write it this way, that is square root of 13 minus 12. The special case is only this. Okay? All right. Beautiful. So, it's getting interested. Yeah? It's getting interested. I hope you are getting excited with what we are doing so far. As I said earlier, there is no rule for adding or taking away subtraction. You cannot add surds by subtraction or addition. Okay? Now, that is what I will say. But when surds multiply the same number, the answer is always the number itself. So, for example, so our distance is becoming huge. All right. So let's stop here. Then we'll continue with the same sets as we meet again. Thank you very much so far. And please go and subscribe and join us again when we'll continue with sets. Thank you.